Hello, ladies and gentlemen. Welcome to Food Safety Fridays. My name's Simon Timpley. It's good to be here with you again this week. Today's guest speaker is Thomas Dunn from Flexpack Technology, LLC. Tom is going to be delivering a presentation this week on printed inks, packaging, protecting food. It's a very interesting topic. All the topics are very diverse. It's the first one on packaging, so we're really looking forward to that. Tom's presented previously in the fall of last year at Food Safety Live, so we know him very well, and I'm sure it's going to be a very good presentation. As I say again, those that the regulars who've been here for the last 5 weeks will know that we've had a few struggles with technology. We're pushing the boundaries of that with live streaming and lots of different internet connections all over the world. We've had a few struggles, but hopefully today, I'm not going to promise that it's all going to go well, but we'll do our best and we'll see how we go. As you know, we've got 45 webinars planned throughout the year. This is number 5. It's turned out to be very popular. As you know, it's free to attend with a free certificate of attendance for everybody. So an absolutely great initiative. We have to thank the presenters for that. Tom today is presenting his time, sharing his time and knowledge with us, free of charge, as are all the presenters. And we have to also thank our sponsors, Safe Food 360, Trace Analytics, FSSC, and IFS. You can find more details about them on the IFSQM website. So thanks to the sponsors. So I'd like to introduce you to Tom. I'll just pass you over. Welcome, Tom. It's nice to have you with us today. Welcome on behalf of all the IFSQM members. You are.
Good morning, everyone.
Yeah. Good morning. Good afternoon. It's 10 a.m. where you are, is it, Tom? EST.
I'm looking at a very pleasant day in Atlanta, Georgia, southeastern United States.
It's great to have you with us. It's 3 p.m. in sunny Manchester today, and we've got 170 attendees from all over the world today, and that's gathering pace all the time. So while you get your presentation ready, Tom, I'll just talk to the attendees about next week's webinar. Okay, so I'll be back in a couple of minutes. So next week we have Elizabeth Stryden from Zimbabwe, and she's going to be presenting on basic hygiene practices for the catering industry. Another completely different topic. I've seen the presentation already, and it's very interesting. It is basic. I'll just read you the synopsis. The webinar will discuss the basic hygiene practices necessary to manage food safety hazards in the catering industry. It covers personal hygiene, equipment, premises, maintenance, pest control, appropriate food preparation and storage practices, amongst other things. May I suggest, if you're a quality manager or a food safety manager in a factory, why not gather a few of your co-workers together, maybe some people off the shop floor, and use it as some refresher training. It is quite basic, but I think it'll be a great refresher. So why not gather around the computer, and everybody gets a certificate. So it's great there to show auditors some continued personal education. Okay, so you can register there, sign up today. Also, I'll be sending out emails, so you'll find out that way. I can see Tom's now got his presentation ready. So I'll pass you over to Tom, and I'll be back afterwards. We'll have some Q&A, but for now I'll pass you over to Tom. Good luck, Tom.
Hello, everyone. Again, printing, packaging, and protecting food is our subject today. One that's very near and dear to my heart. I've spent 35 years now in the packaging business, primarily the flexible packaging business. I worked here in the United States for Printpack, a major flexible packaging manufacturer, and before that with the Flexible Packaging Association, a trade association in the U.S. The primary job responsibilities that I've had are in packaging product development and in regulatory compliance. The processes involved in my career have been flexo and gravure printing, adhesive and extrusion laminating, metallizing and barrier and cohesive coatings. And those processes supported packaging for the likes of salted snacks, confectionery products, ready-to-eat cereal, processed meat, and thermally sterilized food. Currently, I'm a one-man consulting operation involved in product development, expert witness services, and food safety with some credentialing in Hasip and GMP gap analysis as an IFS consultant, and working on food safety certificate with the National Sanitation Foundation here in the United States. I have Lifetime Achievement Awards from the Polymers and Lamination Division of the Technical Association of Pulp and Paper Industry here in the States, the Food Packaging Division of the Institute of Food Technologists, and the Packaging Hall of Fame from the Packaging Machinery Manufacturers Institute. I also published a book this year on manufacturing flexible packaging with processes, products, and technology, published by Elsevier earlier this year. So my overview is to explain to the audience the proactive response, particularly in Europe, to the market recall of millions of euros worth of packaged goods that's now in place to mitigate what previously was an under-recognized and underrated risk to packaged foods. The webinar reviews how those new expectations generated by that response have established safeguards for food packaging for food product processors and requirements for food packaging manufacturers, and specific procedures that should be followed as best practices to assure the safety of their customers' foods. My learning objective is to help you all understand why this is a bad idea. This is a particularly American convention called beer can chicken, which literally involves roasting chickens by placing them over open beer cans and allowing the contents of the beer can, either the original liquid or a substitute, to baste the inside of the roasting meat and keep it moist during the barbecuing or outdoor cooking process. Surprisingly, the approach to food packaging safety here in the States has yet to recognize the fact that this is a very inappropriate use of the beer can as a package, and I hope in my additional learning objectives you'll understand what we as food safety professionals need to understand in this regard. So more to the point, my learning objectives for you today are to place food packaging inks in the context of the Hasip-based risk assessment process, and to recognize that that process generates awareness of the risk represented by food packaging inks to food products. Then understand how those good manufacturing practices for formulating food packaging inks help to provide good protection to the food products. And finally, to understand how GMPs for printing with those food packaging inks further extend the protection to the food products inside printed packaging. So first, I want to give a little background on Hasip-based risk assessment. It systematically reveals food safety hazards from a biological, chemical, and physical contamination standpoint. It identifies what hazards must be mitigated and how to mitigate those hazards dependably and reliably. Hasip is an acronym for Hazard Analysis Critical Control Point. It attempts to prevent hazards rather than test for their presence in finished products. It identifies biological, chemical, and physical hazards in the food supply chain that causes unsafe food products. It designs, implements, and verifies measures to reduce hazards to a safe level. It involves both critical control points and prerequisite programs. And I'll have to admit that in my 35 years in the packaging industry, while good manufacturing practice has been expected of the industry, it's been a mystery as to just what that good manufacturing practice requirement should entail, and it's been a welcome addition to the packaging manufacturing world to apply the Hasip process to its manufacturing operations. So to conduct a Hasip analysis, there are two phases: the preliminary steps and then the basic principles themselves. The preliminary steps are to assemble a Hasip team of knowledgeable process experts in the operation, as well as a knowledgeable Hasip facilitator to go through the analysis itself. That team then describes the product that the analysis will address and understand how that product is going to be used, because those are both very critical aspects of the safety and hazard analysis and mitigation process. With the product in use understood, the manufacturing process in the facility must be described in a flow diagram, and then, as is the case in any good management system, that team gets up from around its conference table and goes out into the operation to actually verify that what goes on in the operation matches their mental picture of it, and verify that flow diagram with the reality of the manufacturing process itself. Then with a good flow diagram, the actual Hasip analysis can be conducted. The hazard analysis identifies control points and critical control points associated with that process from the beginning of the process to the end of the process. For those control points that are critical control points, monitoring requirements are established, and should those monitoring activities identify exceedance of the critical limits, pre-established corrective actions must be in place to direct the organization's response in the context of both embargoing those products and alerting the marketplace about what's going on. And then critical validation of the Hasip system avoiding risk must be conducted to demonstrate, to verify that it works as intended. And finally, the entire process must be managed with record keeping and basic auditing procedures that go along with any manufacturing system. My process flow diagram, this is the simplest concept I can provide for you. The process flow diagram begins with receiving and ends with shipping. Between the beginning and the end are in-plant transfers, raw material, in-process goods and finished goods storage, and then the heart of any facility's process, its value-adding steps, however many there may be. Those steps in the process from beginning to end are arrayed against biological, chemical, and physical contamination concerns, and it's here that the trained Hasip facilitator helps the team take their knowledge of the process and apply it against the basic kinds of concerns associated with these basic contamination types. When those hazards are identified, the need for control point management or critical control point management to mitigate any one of the recognized risks at the specific steps where they are recognized and need mitigation is the design part of the Hasip process next. In the context of mitigating risks, control points represent process flow steps where hazards can be introduced, and those hazards can be mitigated by prerequisite programs and good manufacturing practices, or critical control points depending on the severity of the contamination itself. In the case of every control point, this is a very well-defined event that requires control limits, a chosen monitoring method, and a formal validation and verification system. And surrounding this whole risk mitigation system is a sense of managing with documentation and record control that ensures that the plan is being carried out as expected. So in the context of printing packaging for food, I find that ink chemistry is the most complex chemistry in the whole packaging system. It interacts with other packaging materials and has in fact caused product adulteration and significant market disruption. The Hasip process confirms that inks used for printed packaging materials may present a significant chemical food contamination risk. In fact, packaging is guilty as charged of adulterating its contents. Back in November 2005, Italian authorities seized some 30 million liters of children's milk that were analyzed and found to contain traces of a chemical used in manufacturing packaging inks. Additional precautionary withdrawals were conducted in France, Spain, and Portugal of the same kind of children's milk and the same kind of packaging, resulting in millions of euros of loss of product and opportunity cost as well as withdrawal costs. In March of 2009, the food processor involved in the packager involved were ordered by Italian courts to pay damages and legal costs to the parents of 2 children who drank milk from those contaminated packages. It's not the case that the package designers meant any harm, but in fact, the structure of the packaging involves a printed paper on the outside using a kind of printing process that cures specially formulated ink with ultraviolet light to fix it to the paper surface. The paper layer is then laminated with polyethylene to an aluminum foil layer, and on the other side of the aluminum foil is a second polyethylene layer that serves as the food contact layer of the package itself, as well as the sealant for the formed and filled package. The UV formulated ink contains in it a chemical, in this case called ITX, which serves to cross-link ink and cure it in place with the ultraviolet light. And the design of the package had, in fact, a functional barrier between that printed surface and the food contact layer represented by the dense aluminum foil. But at least as we say here in the States, Murphy's Law always applies. So in fact, the contamination of the product did not occur from the outside of the package to the inside of the package of a given layer, but rather just the opposite. Those layers are typically wound on long rolls of material with thousands of meters of this structure wrapped upon itself, so that the printed surface of one layer on that roll comes in contact with the food contact layer of the next wrap on that roll. And in this case, the migration of the ITX chemical was from the print layer directly to the food contact layer of the next wrap on those rolls ready for form, fill, and seal machines. I don't want to give you the idea that it's only UV inks that can cause contamination. Research continues into the release of components of packaging materials, including packaging inks, from those packages to the product on the inside. This is a study also from Italy, published late last year, of the migration of various mineral oils types and diisopropyl naphthalines from the printed surface of paperboard cartons into, in these graphs, muesli, ready-to-eat cereal, and also there's a series of measurements done on the migration of these same components into pasta, both of which reflect additional market recall experiences in the European marketplace going back about 10 years. So as a result of that real recognition of contaminated food as a result of food packaging inks, the use of good practices while manufacturing inks can greatly mitigate the potential chemical contamination risk to food from printed packaging materials. And in this regard, I want to position the context of good practices from the standpoint of the food supply chain to indicate that, in fact, good practices apply all the way from the agricultural production stages of growing produce and grains and raising meat and fish for the marketplace to the transport of those from the production sites into the processing sites. And from the manufacturing and the processing sites, there are storage and distribution good practices that ensure the safety of the food from the processor to the actual merchandising stage, where additional merchandising practices ensure food safety that's reached the shelves continues to be safe when the consumer buys it. And continuing government and public interest group education helps, we hope, the consumer treat food safely in his environment and getting it prepared and provided for the eventual consumers of the food. So good practices, good agricultural practices, good manufacturing practices, good marketing practices, good storage and distribution practices are defined all the way through the system of food safety management. For food packaging, which is generally considered an indirect food additives, the United Nations sponsored Codex Alimentarius, which is also the source of the basic Hasip process, defines good manufacturing practices for food additives to subject them to the provisions of the standard, such that under good manufacturing practices, the quantity of additive added to the food shall be limited to the lowest possible level necessary to accomplish its desired effect. The quantity not intended to accomplish any physical effect in the food itself is reduced to the extent reasonably possible, and the additive is prepared and handled in the same way as a food ingredient, so its level of purity is appropriate for food packaging. Putting those into practice involves a very basic set of categories of good manufacturing practices that apply all the way from that agricultural stage of the food chain down to the merchandising stage of it. This is from the Codex Food Hygiene Guide, published about 5 years ago. In the context of the European marketplace disruption, the printing ink industry recognized that the ink manufacturer himself does not have an independent responsibility for the formulation and application of inks, but rather it's shared with his downstream printing partners. That shared and final responsibility to be met requires cooperation between the ink manufacturer and the rest of the supply chain. That cooperation is best managed by requirement specifications, detailed information about the substrate, type of food package, printing and converting process parameters, storage and treatment conditions. And it's at this point that I hope it's obvious that none of those communications between the ink manufacturer and the can producer envisioned cooking that can at 400 degrees Fahrenheit for hours on end at high grease conditions that can in fact transfer those ink chemicals on the beer can to the chicken sitting so nicely on top of it. So that when provided with the information from the marketplace, the ink manufacturer is enabled to formulate inks that comply with the regulation when correctly used. And as a response to the recognition of the need, the Printing Ink Association in Europe has established good manufacturing practices for the production of inks and food contact surfaces for food packaging. And in general, these good manufacturing practices map very well onto the hygiene practices of the Codex for food safety in general. What's taken out are things like biological contamination, which typically, well, I should say in some, but not all cases, is much less of a contamination hazard than it is in the case of food products themselves. But I do want to point out that here in the good manufacturing practices, the formulation of the inks is considered a critical control point. And the Industry Association has established a guideline for the formulation of those printing inks back in 2011. It includes specific exclusion criteria. Carcinogenic, mutagenic, and reproductive toxins are excluded, as are chemicals otherwise considered toxic or very toxic. Colorants and compounds containing antimony, arsenic, cadmium, hexavalent chromium, lead, mercury, and selenium are excluded as well. And chemicals considered by the European REACH program as substances of very high concern are excluded. In addition to the exclusion criteria, there are purity requirements for the components of ink, an expectation that the molecular weight of the components exceed 1,000 Daltons. And I'll point out that obviously most of the solvents and solvent-based inks have molecular weight much less than that. But again, in the context of communicating with the printing partners, the ink industry expects those solvents to be evaporated in the drying and ink curing process. And in fact, when that does not happen, contamination can result with odors and interaction of other ink chemicals with the plasticizing effects of those small solvent molecules that otherwise need to be removed from the printed substrate by the printer himself. And there are also migration considerations for the Printing Ink Association guideline. This is the rather sophisticated.
Tom,
Yes.
Simon, sorry, I hope you don't mind me butting in. We did receive a couple of questions sent through prior to the webinar, and one is related to the slide the previous slide. And you was mentioning that with solvent-based printing, that the drying process should evaporate any solvents so that it doesn't contaminate the food packaging. But this person has said that they've got an issue with solvent used in producing wrappers. They've got a solvent odor. So they're having an odor problem with solvent. So what are the likely potential root causes for that? Any ideas?
Depending on the printing process and the specific solvents involved, there are some what printers describe as slow solvents, which are chosen to both lubricate the print media, the engraved cylinders or the printing plates, and provide good release from those print media onto the printing substrate. But at the same time, that lubricity of the solvents makes them difficult to evaporate in the drying operations of printing presses. There are some standard retained solvent test methods described in ISO, or at least the American version of ISO ASTM standards, that provide for trying to use flame ionization detection for residual solvents in printed material. But the standard procedure described in those ASTM test methods is not always clear about how to deal with these slow solvents. So if your press room plans to use slow solvents, you need to understand the retention rate of those solvents in your GC programming technique and work to capture all of those solvents in a reasonable amount of test time to ensure that your printing process is operating on target and in control for complete drying.
Tom, when you say slow solvent, what does the term slow mean when we're relating it to a solvent?
Slow refers to the equilibrium vapor pressure, and so as that pressure, the slow solvents have low vapor pressure, and as such they are more difficult. They require more energy and more air volume to volatilize them and take them out of the liquid form in the ink and remove them from the solid portions of the ink.
Right.
So
on the one hand, we're trying to get, let's say, good print quality and efficient printing production, but that's fighting against the using these slow solvents that's then perhaps got a solvent retention problem.
Solvent retention is the problem, and print quality improvement is the reason for using slow solvents, but the print quality and the solvent retention can work against one another if in fact the process is not adjusted to accommodate for those slow solvents. Yeah. And that adjustment would be in the connection of both the temperature of the drying ovens and the velocity of air at the surface of the printed surface that is removing volatile solvent from that printed surface.
Yeah. So it's about having good GMP control on the press, but also somebody's asked, are there limits for retained solvents? Are there specific limits or not?
There are customer-specific limits, but to my knowledge, there are no sort of generally accepted industry standards for retained solvents. And again, the quantified amount of solvents is a repeatable testing protocol, but that quantity is dependent upon the conditioning temperature and duration, and maybe even a temperature change with the preconditioning of the sample before the GC headspace is sampled. So there's a lot of test method art associated with retained solvent
Yeah.
metrology that needs to be understood by the practitioners and customized for your own printing operation.
Hmm. Yeah. I have, just as an aside, I've seen in some printing operations or some operations where they stand real stock in a warm room for a few days. That must be some to sort of allow any retained solvents to evaporate. Is that a known technique that you've seen, Tom?
There is some of that, and at least my experience here in the States is that the sort of so-called fugitive emissions in printing and coating operations like that have been greatly reduced because they not only can affect the odor of the packaging material being produced, but they can be emitted into the environment around the production facility and contribute to the formation of ozone and smog in the context of air pollution. So for example, the use of enclosed doctor blades has greatly reduced the incidence of fugitive emissions where those emissions need to be reduced.
Right. Okay. There is a couple more come through. While I'm on, so don't interrupt you again, I'll read
Sure.
these out and then I'll leave the others. Somebody's Tracy Barracks White has said glass bottles tend to be non-porous. However, is there any chance of any ink penetrating this material to contaminate liquid contents? So a glass bottle.
Sorry, what is the material?
It's a glass bottle. Is that a full barrier, a glass bottle to inks or not? A glass
In my
bottle.
experience, yes, I'm no expert, but a good index of the barrier properties of a material to ink on one side compared to food on the other is the density of that product, of that material. And obviously, metal cans and glass bottles are very dense compared to the density of most plastic materials, which for many plastic materials is about 1. And for other packaging plastics, I don't think it exceeds 1.5. But the other densities of packaging materials can get into double digits on a gram per cubic centimeter basis.
Yeah. Okay. And another one, Tom. So pretty much glass is like you can't tell without, I suppose, doing the analytical tests, fundamentally the migration tests. But ultimately, glass should be a good barrier.
It should be, yes.
Yeah. Somebody's asked a very wide question. What is a food grade ink?
Okay, I'll address this later, but
Okay.
obviously if you consider pharmaceuticals, pills, you'll find that there are images printed on those pills. There are suppliers of food grade inks who are very meticulous in formulating their inks and basically run their ink formulation operation as would a food processor in terms of safety and contamination concerns. But their ingredients are chosen from materials. I know clay is one of them, and titanium dioxide is another, which themselves can be in direct contact with food under specific regulations of the governing body, FDA in the States, and the European Union regulations in the European Union that allow various materials to be in direct contact with food. It's a very limited supply, and it's a very specific formulation that can be considered a food grade ink. And on food contact surfaces, those food grade inks should be used. This entire European Printing Ink Association effort is devoted towards towards printing on the non-food contact side of food packaging, and I don't know if that reflects a sense that printing on the food contact side of food packaging is to be prohibited in a general sense in the European Union. There are some regulatory niceties that can be put to play in the United States, at least, to allow things like digitally printed messages on the inside of bottle caps for plastic or glass bottles that have a promotional message on the inside that it does in fact come in contact with the beverage or the liquid inside the bottle. And those have a very unique regulatory status that is the subject of its own webinar.
Okay, that's great, Tom. What I'll do, I'll let you carry on because there are lots of questions and comments, and we won't progress with the presentation.
Right.
We'll save some of them to the end now, so you please continue. Thanks for that, Tom.
Okay, this is the last of four, which is actually printing, GMPs for printing with food packaging inks. Now that the printing industry knows how to produce inks with GMPs, using those inks with GMPs in the printing operation can mitigate the remaining chemical contamination risks to food from packaging. What's interesting is that the European effort has allowed the production of safe inks, and the notion of using them safely will result in safe packaging. That European effort has been the result of both the member states of the Union, the scientific community, and the industry groups, EU PIA in particular. While this has gone on in the United States, essentially no change to the law of printed packaging has occurred in the US Fda Regulatory Framework. That framework starts out with the premise that if there is no migration from the ink into the food, the FDA has no authority to regulate it. So that if in fact there is no transfer offset from one surface to the other surface in roll form or stack form, and no migration from the printed surface into the food contact surface, the FDA does not have authority to get involved. If there is migration from that ink material into the food, however it happens, that migrating chemical species must be cleared for the food type and the use conditions associated with the food inside the package. If it's not cleared for that use, the packaged food is immediately considered adulterated and subject to confiscation and withdrawal in the marketplace. And in addition, the U.S. law has long required good manufacturing use in the manufacture of food packaging itself, without providing much specificity at all in the context of what that GMP constitutes, or even more importantly, how to manage those practices on an ongoing basis for efficiency and effectiveness. So the global priority on the integrity of the food packaging chain has resulted in consensus standards for the safe manufacture of packaging materials. And that was issued a little more than a year ago as an ISO technical specification 22002-4, prerequisite programs on food safety, part 4, food packaging manufacturing. So basically, the excuse that nobody can explain good manufacturing practices for food packaging manufacturing does not apply anymore. In fact, those are very well described in this industry and government consensus specification from the ISO organization that reflects a lot of work done by the national industry associations, the BRC, FSSC, IFS, and what have you, in looking at PRPs for their food safety programs. The ISO standard requires that a hazard analysis shall be carried out in these food packaging manufacturing operations. And in particular, for chemical contamination from ink migration, printing and coated materials shall be handled and stored in such a manner that the transfer of substances to the food contact surface via offset or other mechanism is reduced to a safe level as defined by the hazard analysis. So not only are good manufacturing practices required by this ISO standard, but also their management in the context of the good manufacturing system is envisioned. In addition to the European guidelines, there's a current legislative effort being conducted in Germany that may result in a German printing ordinance year after this that is assumed to be the eventual standard for all of Europe. It will include a positive list of evaluated substances, an overall migration limit, specific migration limits for some chemicals, and a provision that if those substances in the ink are not evaluated by this ordinance, they shall be limited to a detectable level of 10 parts per billion. And that's a level in the ink, not in the food packaged in those packaging materials. So the basic kind of critical control point technique that a printer must use is to use the ink meeting the European Printing Ink Association selection criteria, which right now represents the world-class definition of safely formulated inks. Then the printer must print on target and in control with his drying and curing process. And this relates to the solvent retention issue that I described earlier. If you change your ink, or if you change your substrate, or change your operating speeds, then this process may well change, and you need to, again, validate migration levels and confirm that there's no contamination of the food or odors or other kinds of contaminants present in the packaging material. And then I suggest finding a way to verify that drying and curing manufacturing process while it's being conducted in short turnaround testing, things like rub resistance, solvent resistance. It could be this retained solvent test using gas chromatographs. It could be product resistance. This is very much a product package material specific verification process. And then, of course, prepare an action plan when the verification process indicates that an out of control material has been produced. So just in summary, Hasip is the best practice for food chain safety management. Packaging inks represent a chemical risk primarily. Migration to and offset from the inks onto the food contact side of materials is the problem. Molecular weight control, heavy metal content, toxicity, and general toxicity are required for formulating safe inks using good manufacturing practices. Then printing with those safe inks at the printing level requires GMPs and PRPs and a control point approach as appropriate based on a Hasip analysis. And in that way, I hope the packaging industry can deliver to the marketplace packaging materials safe for the food inside of them. And here's contact information. I didn't realize it when I set up my consultancy, but Flex Technology is not intuitive word to spell, so I've given it to you here in a couple of places. And with that, I thank you for your attention and invite questions from Simon or the audience going forward. Thank you.
That's great, that, Tom. Thanks very much for that. That was excellent. I can tell because there's lots and lots of questions and comments and interests coming through. I mean, one question I do have actually. I mean, you've got all your GMP in place, all your controls, but then the check on that is the migration testing of the finished product that's been through the process. So once you've done your baseline migration testing and everything's okay, what frequencies should you retest, redo migration? Because I've seen various standards. For example, if nothing changes in your process and if nothing changes with the ink formulation, in theory, and nothing changes with legislation, in theory, you're running on a known standard. But what do you see? Are there any guidelines, or what do you see in practice, Tom?
Yeah. Well, the Hasip analysis is intended to be based on scientific fact, so that initial measurement of migration provides the basis for your initial hazard analysis. But in spite of all the things that you described as not changing, the control of the manufacturing process is very difficult to monitor and ensure on an ongoing basis. So I recommend to clients that they repeat their migration testing on at least an annual basis. And depending on what kind of manufacturing process control they have in terms of ISO 9000 or 14000, whatever shop floor control the management of the operation has, maybe a 2-year cycle. But in fact, I tend to find that the Hasip analysis is done once, and just given cursory attention on its obligatory annual review, and the migration testing is not done on the current manufacturing process with whatever change may have crept into it over the course of the last 12 months. Okay. So that there's best practice, I'd say, is at no longer than a year, but average practice is much longer than 12 months.
Very expensive program. It can be. Tom, do you want to stop your slide share so that we can see you on the webcam while I get another question? Somebody has also asked, does the GMP sort of regulations apply to secondary and perhaps even tertiary packaging?
Well, the position I take is that answer lies with the Hasip analysis, and that if in fact your secondary and tertiary packaging materials are reviewed in the course of the Hasip program for your packaging process in general, as a food processor, it may be the case that the hazards that remain after your product has already packaged in its primary package are minimal to none in the secondary or tertiary package. But that, again, depends on the specifics of your Hasip analysis, the hazard analysis, at least, part of your management system.
Yeah.
So the person using glass bottles may well have, in effect, a hermetic package that is well protected against breakage or other sorts of post-shipping contamination by primary virtue of the primary package. But the overall integrity and performance of those secondary packaging elements should be confirmed as part of the hazard analysis.
Okay. Let's see. Oh yeah, I did have one. This was again one that was written in prior to the webinar. What part of 21 CFR applies to printers and manufacturers of food packaging? And that's from a member of the forum, and they're specifically using digital print technology with HP inks.
Right. So this goes back to the comment that in the United States, FDA, which is the steward of 21 CFR regulations in the state, does not have a legal position if those ink chemicals do not migrate into the material. So that requirement for the migration study as part of the printer's Hasip analysis would identify any chemicals migrating from a digital ink or any conventionally applied ink through the packaging material or offset on the packaging material and getting into the food itself. So few, if any, inks can claim they are compliant with 21 CFR. Those that are comprised of chemicals and materials otherwise cleared in various portions of 21 CFR for food ingredients or for coatings or other kinds of food packaging indirect additive clearances.
Okay. Hopefully that answers that one for that member. Just to clarify, Tom, during the presentation you referred to two types of migration. Taking a printing process, printing reel to reel, for example, on some sort of plastic-based substrate. In your experience, is the greater risk the migration through the material from the top surface to the food contact side, or on winding through the set-off? What's your opinion on that?
My manufacturing experience is primarily involved with buried print laminations, so that that opportunity for surface printed material to offset to the food contact surface in roll form or stack form, I had minimal experience with that scenario. So in fact, when I've tested for ink migrating from that buried print layer with a covering film on the outside and some sort of additional sealant film or barrier film inside the ink, I find with inks that do not have these small molecular weight components in them, the standard migration protocols show that in fact there is no migration, which is the basis of the FDA handling of the food on food packaging material, of the inks on food packaging materials. So the standard protocols for migration testing, when applied to the food packaging used in mass-produced flexible packaging applications, in my experience, have not demonstrated any migration into food simulants on the laboratory testing.
Yes. Okay. Let me see if there's one or two more. Somebody was asking about sort of Tetrapack packaging. What are the hazards for that in relation to migration? I imagine that's quite a good barrier. Is it the Tetrapack material?
Yes, the Tetrapack package itself is a good barrier. I know Tetrapack has taken to heart these good manufacturing practices for the ink formulations that it uses, and it is a very rigid adherent to the expectation that the inks it uses will meet that European Printing Ink Association guideline for formulated inks and for manufacturing using good manufacturing practices. And in addition, the inherent Tetrapack process itself involves inline packaged material sterilization with the aseptic packaging of the products typically placed in the Tetrapack packaging system, so that any contamination on those materials that's not absorbed into the food contact surface will be washed off by the sterilizing process.
Okay. We've talked about UV inks, we've talked about solvents. Somebody's mentioned water-based inks. Just the sound of it, water-based, it sounds nice, sounds okay. Have they got any nasties in them, water-based inks, that we need to be concerned about?
Many times a water-based ink is managed for its press quality with a pH adjustment, and that pH adjustment often involves addition of ammonia, which, as you can imagine, if you're washing a floor with an ammonia-based cleanser, can have a very pungent odor to it. So just because it's a water-based ink doesn't mean it's a odor-free ink. And so just as with solvent inks, the need to volatilize any of these liquid components of the ink that are intended to be evaporated and dried in the ink curing process need to be fully completed in order to avoid tainting packaging material with a residual odor or a chemical that can migrate into the food itself.
That's an interesting point, Tom, actually, that a chemical that smells and gives off an odor isn't necessarily unsafe in terms of being a nasty chemical, whereas, let's say, something without really any odor at all could be a nasty chemical. But let's say a customer receives some packaging that's, gave off a smell, or a consumer might actually not be a real problem with it. Actually, might be low migration inks, for example. Am I right there in saying that?
Well, I think there's a nuance that has to be considered in that regard. Just about every food packaging safety legislation that I've reviewed has prohibited the packaging material from having any effect on the taste or odor of the food package in that material, just as a definitional consideration, so that even if that odor of the packaging does not cause harm to a consumer of the food inside the package, there's a good chance that that packaging material is not legal for use. And in the case of the ITX contamination in the children's milk formula, I think some considerable research by the European Food Safety Authority confirmed that ITX itself did not pose a health hazard to people consuming that ink, but in fact the withdrawal from the market before that sort of epidemiological finding was confirmed created a huge economic impact, although thankfully no injury or death to the consuming public. And similarly for the other UV ink components that were found in the muesli and the pasta products, nobody was harmed with those either. So if it's not critical to the function of the packaging material, it should not be in there. And that's a basic tenet of the good manufacturing practice defined by the Codex.
Okay.
Food
Okay.
Guide.
We've got another one here from Zach. How do we determine what compounds should be part of your migration testing? What should the test be looking for? Any standards or lists of chemicals to look out for?
Okay. Well, the presence in the European system of positive lists is a good starting point. You should find nothing in a gas chromatograph mass spectrophotometer that is not on that list, and if it is, you should go another level deeper in your analytical technique to identify and quantify what is not identifiable as on your positive list. In addition, there's the basic gravimetric limit that the new German legislation is suggesting. Again, what was that? 10 milligrams per decimeter. My metric measures are not that good, but it's the same as the plastics guideline. And then you have specific migration limits so that materials of concern that are allowed in the inks are not present above a certain level based on a quantification using chromatography methods. And of course, any of the excluded materials should be tested for in a GC-MS test so that you're below the limits of detection for your particular method and have a good validated test method for those detection limits. And again, I would refer to the good European research on the plastics packaging regulations that go into good detail on migration, simulation, and quantitation with test methodology.
Great. I'll just take one more, Tom, because we are coming up to the hour mark now, and I don't want to keep you and all the attendees that have got plans. But just one about further sources, further research. Do you know any good references, any good sources of websites and things to find out more information, apart from, of course, this webinar and future webinars that you may be doing, Tom?
Well, I'll direct anybody with an interest in that back to that slide that had the research on the mineral oils and the journal. It's an Elsevier published peer-reviewed journal of packaging research, and that journal debuted last summer, if I'm not mistaken, and inherent in the mission of that journal is the research on these kinds of chemical migratory issues coming from packaging materials that would contaminate food inside the package. So if you have a compelling interest in this, at least keep track of the research being published in that journal and get the articles that are published on an as-demand basis if you don't want to subscribe to the journal outright.
Yeah, I know there is one also an organisation called Flexible Packaging Europe, and they have a very good email update on all the developments and sort of technical committees on the food
yes.
food contact legislation and things. But we'll put some, when we send the email out, we'll put some links in there for further information.
Good idea, yes.
Yeah, what I'll do is everybody will get a copy of the slides that has registered for this webinar, and we'll be sending that by email with the recording to the webinar. So you'll get the recording, the slides. We'll send you some more links, and we'll also capture all these questions that have come in on the side here, and we'll post them on the discussion forums so that we can have a look at those on there. So I'll just say thanks very much, Tom, on behalf of everyone at the IFSQN, from me personally, and for all the people that have logged on today. It's been really a great insight, and definitely looking forward to the. You've got another 3 throughout the year, I believe, so that'll be great.
Yes, sometime this summer will be another subject.
Yeah, well, we'll let everybody know about that. So. Thanks very much, Tom. You're done now.
Thank all of you, and feel free to send along other questions.
Okay. Cheers, Tom.
Thank you all.
Okay. Right. Just for the attendees now, I'll just pop in the certificate there. If you look in the tab at the top, the pop-ins, you can download your certificate now. Go over to the IFSQN website and grab your certificate. If you don't manage to get it today, like I say, we'll be sending a link to the video, the presentation slides, and also the certificate, so you will get that. And if you don't get that, you can always send me an email at team@ifsqn.com. Please register for next week's webinar. If you can't attend the live webinars, it's really important that you still register in order to get the email with the links and all the information. So thanks very much, everybody, for attending again. It's been a really good session. I've enjoyed it. It's gone a lot smoother than previous ones. I've really enjoyed it. So look forward to welcoming you all next week again. Join us online. It's Friday. That's a great bit of news. So have a nice weekend, everybody. Take care.